and tell me about your research project.
Sure. So my name's Benjamin Kim, and I'm an ophthalmologist and retina specialist at the Shea Eye Institute of the University of Pennsylvania. And I conduct research on age-related macular degeneration, or what we call AMD. And in particular, we're studying what's called the geographic atrophy form of AMD, which is where patients can develop patches or areas of their central retina where the retinal tissue doesn't survive, and you actually develop blind spots in those areas. And then those blind spots can enlarge over time, leading to significant blindness and legal blindness. And the major thoughts about why this happens involves a significant aspect of oxidative stress and potentially iron overload that can contribute to oxidative stress in the retina, causing the retinal tissue to not survive. And there actually is a supplement called alpha-lipoic acid, which is known to be a very potent iron chelator and potent antioxidant. And my collaborator, Josh Danaeff, who also has a large role with the Bright Focus Foundation, has produced pretty remarkable animal model data suggesting that lipoic acid could be very protective of the retina in this type of situation. And so given that this is a oral available supplement that has a good safety profile, a lot made sense for us to develop a clinical trial. And so we developed a pilot phase 2 clinical trial testing alpha-lipoic acid as a treatment for the geographic atrophy form of macular degeneration. And we're very happy to say that currently the trial's fully enrolled. We have more than 50 patients across the country at 5 clinical sites, and we're scheduled to finish the study by the spring of 2019.
Oh, that's fantastic. What do you hope your research is able to achieve?
So, the geographic atrophy form of AMD is by itself expected to be causing about 20% of the legal blindness in North America. And so that's tremendous. And so if you think about some of the major causes of legal blindness around the world, cataract, glaucoma, diabetic retinal disease, or perhaps the wet form of macular degeneration, those are all things that have some type of treatment that can help patients if they have that. But the geographic atrophy form of AMD is actually pretty tough, because when we see those patients as clinicians, we currently have really nothing that we can offer them. And so we are trying to find a treatment that can slow down this disease and give patients more years of better vision.
What inspired you to become a researcher?
I've always been interested in science and medicine. It was a very natural progression for me to go from college to medical school, and I think as I thought about whether I wanted to mostly or only see patients as a clinician or have a component of research to my career, I really wanted to be doing both, to have the interplay of patient care and science, just because there's always been a curiosity that I think is driving me in terms of asking, why are these diseases developing? What are the molecular underpinnings of disease? But then also closely related to that is the desire to have the larger impact that one can have on patient care through research. So when you're seeing patients, you're helping people one patient at a time, which is incredibly personal and important for you and that patient. But if you make a major scientific discovery, you can change the face of medicine. You can help many people at one time and across the world. And so it's a different way of trying to have an impact with the work that I do.
Great. What message would you like to share about the importance of scientific research?
So I think, it's as simple as walking through a hospital or going to a medical clinic. We know there's, despite the many, many scientific advances that we've had, there's so much more that's left to do to help people with various diseases, whether it's AMD, glaucoma, or Alzheimer's disease, for example. And it's really only through research that we're going to get there, and only through research that we're going to push the envelope and improve patients' care and patient lives, because you need the data to show that your therapy or your management plan is going to help people. And you need the basic science to develop the therapy. So it's all really the only pathway to help push medicine to improve.
Mm-hmm. Would you like to say anything to our donors who might be watching this interview right now?
Sure, happy to do that. Bright Focus, the foundation that Bright Focus has, and philanthropy in general, really plays a key role for researchers, I would say now more than ever before, just because while there is government funding from sources like the NIH, you have to have a pretty developed program to get the government funding. And so there's a real key place for philanthropy and foundations to help researchers get projects up and running and off the ground that then can transition to greater things. And so as an example, our pilot phase 2 clinical trial, I can pretty much say definitively that this would not have risen off the ground without the Bright Focus Foundation. Mm-hmm. It was the funding from Bright Focus that helped snowball this into something that went from an idea that was talked about to now a fully enrolled clinical trial that other foundations also jumped on and wanted to support once they saw that Bright Focus was a founding funder of this project. And so whether it's small or large, everything makes a difference when you're working with a great foundation like Bright Focus.
That's great to hear. What excites you the most about current trends around your area of research?
So I think for the reasons that we were talking about how devastating geographic atrophy and AMD can be for patients and what a major cause of legal blindness it is, there's actually an incredibly vibrant and exciting race to find a treatment for this. And both industry and academia have many people and major players and many dollars going into trying to find a treatment, because we have literally nothing for this right now. And people are looking at varied approaches from antioxidant therapies to immune modulating therapies to stem cell therapies. And so it's an incredibly dynamic area of research. And there's actually some competition among these groups, but what we all have in common is we're trying to find a treatment for this disease process.
Absolutely. So what's something that people may not know about working as a researcher?
I think that when I reflect about what my daily life or weekly life is as a researcher, it takes a tremendous amount of persistence and determination. I think that every scientific discovery story has within it a rich story of that scientist going through the ups and downs of trying to figure something out and trying to march forward with determination to try to take an idea to fruition. And all researchers experience that. And so sometimes the most exciting part is having the idea come into your head, but then you have to take it from point A to B and beyond to see it come to fruition. You can think of that very well-known quote by Thomas Edison, who invented the light bulb, right, where he said that genius is 1% inspiration and 99% perspiration. And so you have to be ready for the 99% perspiration to get you there.
Yeah, absolutely. So how do you describe your technical research to your family and friends?
I think that compared to someone that's doing really in the lab research, I have a little bit of a leg up when I'm discussing this with family and friends, just because we have a lot of immediacy to our project. We're not studying an animal model or something in a test tube. We're really taking something that has already gone through that process and trying to translate it into a clinical treatment eventually. We are already at the point where we're saying, let's take patients, let's find patients with disease, let's offer them a study that can give them hope and say, well, we're going to give you either a placebo or this drug, And then we're going to find out at the end if there's something behind this that might be helpful for what we're dealing with.
Right, absolutely. Well, thank you so much for taking the time to speak with us today. It's been a pleasure. And to all of our viewers out there, we will be back again, and we will be interviewing another researcher in a few minutes. Thanks for tuning in.
Thank you.